Welcome back to instance level settings. Moving on to the database settings within the SQL Server instance, we have the default index fill factor, the tape backup settings, the default backup compression setting, and the recovery interval. The default index fill factor tells the SQL Server what fill factor to use when creating new indexes by default. This is set to 0 by default, meaning that all pages should be full. Realistically, you're probably going to want to change this to some other setting. Most of the time, the only indexes we want to have a fill factor of 0, or to fill the pages completely, are clustered indexes which are built on numeric values, which are always increasing, like identity columns, columns using sequences, or columns that using date-time values. The tape backup settings, for the most part, aren't going to get used. We'll look at them in more detail when we get into the demonstration. The default backup compression setting is going to tell the SQL Server what compression setting to use by default, if it should always compress the backup, or if it should never compress the backup. The recovery interval tells SQL Server how often to force a checkpoint to happen. The database settings also specify the default database file locations. We can specify default locations for 3 different settings: where data files should go by default, where log files should go by default, and where backup files should go by default. If you don't specify a backup location when doing a backup, it's going to stick it in this location. This is also used for maintenance plans. The next section is the file stream settings. This allows the instance to host the databases which use the file stream feature. It also displays the network share name for the file stream data. File stream is configured both in Management Studio and in SQL Server Configuration Manager, so you have to set it in both places to get file stream correctly configured. On the network page, we can set the network packet size, which realistically we probably don't want to change unless we've made changes to all the network devices between our end users and the SQL Server. We can set the remote login timeout as well, which tells SQL Server how long to wait for somebody to connect before it actually fails the timeout. On the parallelism section, we can set the cost threshold for parallelism, which tells SQL Server how expensive the query has to be before it can be parallelized. This setting is set at 5 by default, but typically we want to increase this to a more realistic number, as queries that only have a cost of 5 are not that expensive. When I'm working with clients, I typically recommend setting this at 40 and then adjusting it as necessary based on what queries we see being parallelized and which ones we don't. We can also specify the number of locks that are available on the SQL Server. We typically want to leave this at the default setting, although there are cases where we need to increase the number of locks that SQL Server can allocate because of the workloads that are running on our server. We can also set the max degree of parallelism, and some people use this setting to turn parallelism off by setting the max degree of parallelism to 1. This is not recommended in really any workload. If you're seeing parallelism issues, setting the max degree of parallelism to 1 does not make the problem go away. It simply masks the problem. Because we're not resolving the long-running queries, we're simply turning off parallelism so that we don't see those weights showing up as CX packet. We can also specify some max query wait timeouts, which we can specify as well and change as necessary. Let's go ahead and look at all the various settings that we've just talked about within Management Studio so we can get a better idea of where they all are. As you can see, I've got a system set up here, and I'm connected to it through Management Studio. All those various settings that I've just talked about are all located in one place by right-clicking on the instance and selecting Properties. On the General tab here, you can see a bunch of various settings that you can't actually change. These are simply reading settings from the server to see what it's got. You can see the name of the physical machine, the product we have installed, the operating system we have installed, the platform we're running on, 32-bit, 64-bit, or Itanium, the version of the instance that's installed, in this case, SQL Server 2012, build 2218. The language of the software that's installed, in this case we're using US English. The amount of memory installed on the server, in this case I've got 48 gigs installed. How many processors are available to the server? It's these 8 logical cores. The root directory that SQL Server is installed in, the collation of the instance, whether this instance is clustered, and whether or not this instance is configured for always-on availability groups or HADR. On the Memory tab, we can see the memory settings we talked about before. We can see the minimum and maximum memory settings set with their default values. The minimum default value is 0 megabytes. The maximum default value is 2 petabytes. We'll want to adjust both of those based on the needs of our system. As we have 48 gigs of memory on this server, a good number might be 42 gigabytes of memory to set the instance to. We can see the other memory options with the index creation memory and the minimum memory per query in kilobytes. Index creation memory, we typically want to leave that at 0, letting that remain dynamic. We don't want to limit SQL Server to the amount of memory it can use for index creation unless we've got a really good reason to. This is a very advanced configuration setting, which should not be done on 99.9% of systems. On the processors page, we can see the affinity mask, and we can see the I/O affinity mask settings. We can set those as necessary. We can also see the maximum number of worker threads. We want to leave that as 0. We want to let SQL Server manage that for us. We can see the Use Windows Fibers lightweight pooling setting and the Boost SQL Server priority settings as well. We want to leave those two settings disabled in almost all cases. If you think you need to enable those settings, you're probably wrong. On the Security tab, we can see the server authentication options. We can see that this server is set for Windows Authentication mode, meaning I cannot use a SQL Server authentication account to connect. We can also see the login auditing option, which I mentioned earlier. It's set for the default right now of failed logins only. We can specify none, failed logins, successful logins, or both failed and successful logins, depending on our requirements. We can see the proxy account, which is disabled, and should usually remain disabled. Again, unless you have a specific reason where end users need access to run XP Command Shell. We can see the options at the bottom there to enable common criteria compliance, C2 auditing, and cross-database ownership chaining. On the Connections tab, we can specify the maximum number of concurrent connections. Again, we typically want to leave this at 0 or unlimited. We can specify that we want to use the query governor to prevent long-running queries, and what the timeout option is that we want to specify in seconds. The default connection options are listed there as well. The various options include implicit transactions, cursor close on commit, ANSI warnings, ANSI padding, ANSI nulls, arithmetic abort, arithmetic ignore, quoted identifier, no count, ANSI null default on, ANSI null default off, concat null yields null, numeric round abort, and exact abort. How you set these settings will change how the clients connect to the SQL Server and how things work within the SQL Server. Some of these settings are newer. Things like no count, turning that on at the instance level, can be a good thing if your users are running queries that return a lot of row count messages back to them over a slow network link. Allow remote connections to this server specifies that we're going to allow linked servers to come into the machine. Required distributed transactions for server-to-server communications requires that all transactions that are run across a linked server are going to use a distributed transaction. You can turn these settings on or off as you need. The allow remote connections to the server is enabled by default with a query timeout of 600 seconds. I don't typically recommend setting this for no timeout unless you know that you're going to have queries coming across a linked server running long queries and you find this acceptable. Data warehouses, data marts are typically the systems that we would see this set for an extremely long period of time in. Typically in OLTP applications, we wouldn't want long-running queries coming across linked servers. On the database settings page, again, we can see the default fill factor, the backup and restore media settings, the compression setting, which is simply a checkbox saying yes or no, the recovery interval in minutes, and the default database locations for data, transaction logs, and backup files. We'll go ahead and continue this demonstration in the next video.